Hello everyone, welcome to my channel. Now in this video I am going to discuss the chapter work, energy, power. Now this work has different meaning for different people. Like when you're doing your homework, so that is a work. When you are playing in the field, that is a type of work. When you are cycling, that is a type of work. A farmer working in his field, that is a type of work. But in physics, how do we define work? How do you define power? How do you define kinetic energy? What are the different forms of energy? Those things we'll be studying in this chapter, work, energy and power. Now before we go into the details of the chapter, we need to brush up our concepts on a topic called the dot product. Dot product. Now suppose these are two vectors, this is vector A and this is vector B, and theta is the angle between A and B. Then component of A along B, if this is A, this is theta, component of A along B will be A cos theta. Similarly, component of B along A will be B cos theta. Now how do we write A dot B? We write A dot B as, we can write it as either component of A along B multiplied by B, so we can write it as A cos theta into B, or we can write it as component of B along A multiplied by A, so that is B cos theta into A. So this can be written as A dot B is equal to A B cos theta. So this is dot product of two vectors A and B. Now how do we apply this in defining work? Like suppose this is a horizontal surface, assuming the surface is smooth, and this is a block placed on this horizontal surface, and this block is acted upon by a force F, so that the displacement, this block is displaced in this direction. Theta is the angle between the direction of application of force and the direction of displacement. Now this force has two components, one component acting along the displacement, so this component is F cos theta, and one component acting perpendicular to the direction of displacement, this is F sin theta. Now F sin theta is the component of force perpendicular to displacement, F cos theta is the component of force parallel to displacement. Now displacement is taking place in this direction. Okay, so that means this force is responsible for displacement. So while calculating work done, the component of force which is perpendicular to the displacement, it does no work. No work is done by this component. So the only component which can do work, component of force which can do work, is the component of force which is acting in the direction of displacement. So we are least bothered about this force. Okay, at present. Now, so how do you define work? We define work as the product of component of force in the direction of displacement and the displacement magnitude of displacement. Okay, so this is W is equal to F cos theta into S. So this can be written as W is equal to F dot S. So this is the mathematical form for work done. Okay, or I can write this as W is equal to Fs cos theta. W is equal to Fs cos theta. Okay, now there are implications for this result. What are those implications? So we have W is equal to Fs cos theta. So we have W is equal to Fs cos theta. So now work done will be 0 if there is no displacement. If there is an action of force on the object but there is no displacement, then work done will be 0. Okay. Work done will also be 0 if there is no force acting on the object. There is no force acting on the object. In that case also work done will be 0. Work done will also be 0 if force and displacement they are perpendicular. Okay. So for all these cases work done will be 0. Now in addition to this, see, we know that in the Cartesian system, first quadrant, all trigonometric functions are positive. In the second quadrant, it is sine. In the third quadrant, it is tan or cotangent. And in the fourth quadrant, it is the cos or sec function. Okay. So in the first quadrant all are positive. So that means, see, if theta, if this angle between force and displacement, it is greater than 0 degree and less than 90 degree, in that case work done will be positive. Work done will be positive. Now in case theta is greater than 90 degree, less than 180 degree, that means it is in the second quadrant. Now second quadrant only sine is positive, cos is negative. So if cos is negative, this work done will be negative. So in that case work done will be negative. So these are the few basic concepts related to the term work done. When work done is 0, when work done is positive, when work done is negative.